Questions from recent homeworks? Anybody got anything?
Chapter 3, number 12.
From the problem set?
Yes. I didn't do this. I'll do it. All the stuff that I made.
All right. So first thing I want to do is identify, stop talking please, is to identify the values for A, C, H, and K. If I'm looking at this, it's already in that standard form for me, right?
Yeah.
So the A is a half, C is 1, H is pi over 4, and K is 1. So I'm going to go and write my transformation map. Since this is a sine function, I'm going to be using the key points for sine. Those are on that reference points sheet in the content library.
For the test, will you give us the reference points?
Yes. So when I plug 0 in for x, I just get 0 plus pi over 4. And then 1/2 times 0 plus 1 is 1. And then pi over 2 plus pi over 4 is 3/4. And 1/2 times 1 plus 1 is 1.5. Pi plus pi over 4 is 5 pi over 4. And then 1/2 times 0 plus 1 is 1. 3 pi over 4 plus, or sorry, 3 pi over 2 plus pi over 4 is 7 pi over 4. And then 1/2 times -1 plus 1 is 1/2. And then 2 pi plus pi over 4 is 9 pi over 4. And then 1/2 times 0 plus 1 is 1. So now I'm going to graph this. So it says to graph this from -2 pi to +2 pi. So I'm just going to go by quarters of pi. So I'll make this like my x-axis. So -1/4, 1/2, 3/4, 1, 5/4, 6/4, 7/4, 8/4, which is 2 pi. Do the same thing, go in this direction. So 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8/4. And we'll go up by halves here. Cool so far?
Yeah.
Okay. So I have pi over 4, 1, 3 pi over 4 and 1.5, 5 pi over 4 and 1, 7 pi over 4 and 0.5, oops, 1 is here, dummy dum-dums, sorry, 7 pi over 4 and 0.5, And then 9 pi over 4 is like off the chart, but I'll just put one extra tick mark in there so I can put it in there. So there's that part. And from here, I'm just going to kind of continue the pattern. So I go minimum, back to midline, up to maximum, back to midline, and then one more tick mark would put me down to minimum. And there's my picture. Does that feel okay, Nate?
Yeah.
Okay. Anybody else? Okay. Let's pick up where we left off yesterday. And my computer is being the laggiest piece of laggy that it's ever been. So we're going to start by going back and talking about these 4 attributes that we had to describe the graph of one of these sinusoids. Remember, sinusoid is just the generic term for one of these wavy-looking graphs. The graph of sine and cosine are both considered sinusoids. So if we remember here, the midline was like this horizontal line that divides the graph into 2 equal pieces. So I have an equal amount of graph above the line and an equal amount of graph below the line. So y equals sine x or y equals cosine x, that midline was just the x-axis, the line y equals 0. The amplitude was the distance from an extrema back to the midline. So for sine or cosine, that was just 1. The period was the length of one the longest non-repeating section, the horizontal distance. So for sine and cosine, that was 2 pi. And the frequency was always just like 1 over the period.
Frequency is always 1 over.
Yep. Oh, come on. All right. So let's do the same thing now, except let's talk about the transformed version of these. So, what type of transformation or transformations could affect the location of the midline? K, very good. So if I'm shifting the graph up or down, that's going to change the location of the midline. Everybody agree with that? So if I shifted the graph up 3 units, the new midline would be at y equals 3, 3 units up. So the midline in general is just going to be y equals k. Okay, let's talk about the amplitude. What type of transformation or transformations will affect the amplitude? A vertical stretch or shrink. Very good. So if the amplitude was originally 1 and we stretch it by a factor of 2, what will the new amplitude be? 2. So our amplitude is just going to be the absolute value of A. Why do we have to include that absolute value? So it's positive because the amplitude is a distance, and it doesn't make sense to have a negative distance. And that A value could be positive or negative. Good. The period, that's like the horizontal length. What type of transformation will affect the period? It's not the H. It's going to be, it's going to be if there's a horizontal stretch or shrink, right? If we stretch that out, the period will get longer. If we shrink it down, the period should get shorter. So the period is going to be 2 pi times the absolute value of C. Why are we putting the absolute value there? To make sure that it's positive, because the period is a distance. So it needs to be a positive number. And if the frequency was just 1 over the period, then we have just 1 over 2 pi C. Is everybody okay with what we've done here? So this information would be an excellent thing to include on your note sheet for the test. I would think that that would be information that I'd want to write down. So let's say that we have the function y equals -7 cosine of -2x minus 6 plus 2. And we want to find the midline, amplitude, period, and frequency for these, or for this function. What do we need to start by doing? Got to find the values for A, C, H, and K. Very good. So to do that, what do I need to do? Great. We got to make sure we've written this in the proper form. Is it in the proper form currently? Not completely. So let's go ahead and start by doing that. What do I need to do? This is the problem part, right? So I would take out not a 2, but rather a -2. Okay. Oops. Okay. But that's still not in that general form, right? Yeah, how do I write -2 as a unit fraction? Yeah, I write it as 1 over -1/2. And then this is supposed to be a minus there. How do I write +3 as a subtraction problem? Yeah, minus a negative. Is this going to show up? What's going on here, computer? Wow, we're like the slowest this computer's ever been. Sorry for the delays here. What else is on here running that doesn't need to be running? That doesn't need to be running. You can stop doing what you're doing. I don't know if I probably need that up and running. All right, that's probably help me out a little bit. Okay. So my values for A is -7, C is -0.5, H is -3, and K is 2. So the midline then is going to be, okay, so y equals 2. Yeah, Mr. Kulik is going to be picky about that. If you write down the midline as a number, I'm going to mark that wrong, because the midline is a line. It needs to be written as the equation of a line. So it has to be written as y equals something. Sure. Okay, so just be warned, Mr. Kulik will be picky about that. The amplitude is so the amplitude is 7. Great. And then the period, so 2 pi absolute value C, which is just going to be pi. 2 pi times a half, which is just 1 pi. And then the frequency is the 1 over the period. So there's that. Right? No big deal doing this. Pretty easy. Agreed. This is over here. All right. What we're going to do next is we're going to start talking about how to go from a picture of the graph to the equation. So let's look at some examples here. That turned out a lot smaller than I thought it was going to come up. I don't like that either. Let's try doing it this way. I don't like the way that's looking either. Do this first. Try it again. That didn't turn out very well either. All right, we're going to give this one more shot. And then just Mr. Kulik's going to deal with it. There, that looks a little better. All right. So let's say we want to write the equation for this sinusoid. So that means I'm either going to write a y equals a times sine 1 over c x minus h plus k, or a y equals a times cosine 1 over c x minus h plus k. So remember yesterday when we were looking at the graphs of sine and cosine that we created? You remember how they were really just the same graph, just translated left or right a little bit? So any problem like this I can answer either as a sine equation or with a cosine equation. I can do it both ways. Now the numbers, the a, c, h, and k might be different, but the equation, but the answer is acceptable to do it both ways. Okay? So my first order of business is I want to find these values for a, c, h, and k. What tools am I going to use to do this? I'm going to use these guys. So I'm going to pick off the key feature from the picture and use it to find values for, well, a, C and K. We'll talk about how to find H in just a moment. Everybody cool with that plan? Okay. All right. So Mr. Kulik likes to start by finding the midline, which looks to be this spot right here. Everybody agree that that's dividing it in half? That is the equation y equals 0, which tells me the value for k is going to be 0. Everybody okay with that? Okay. The next thing I'm going to look for is the amplitude. So the amplitude is the distance from an extrema to the midline. So that amplitude here is 2. So what does that tell me? No. A is 2 or -2. Right? Because the amplitude is the absolute value of A. So A could be positive or negative. We don't know which yet. Okay. Next thing we'll find is the period. What was the period again? Okay, but in words, what are we looking for in the picture? Yeah, the longest non-repeating segment of my graph. If I look at this, that's the whole picture, right? Yeah. I just have an up and then a down, and that's the whole picture. So this whole thing is going to be my period. So we're starting over here at -2 pi. And we're ending over here at +2 pi. So how long is that? 4 pi. So I can say then the period, which is 2 pi c, or absolute value c, is equal to 2 pi, or equal to 4 pi. If I divide both sides by 2 pi, I get that c would be 2 or -2. Okay. Is everybody okay with that? Okay. So I have 3 things left to kind of figure out. I need to figure out whether the A is positive or negative, the C positive or negative, and then I still have to find that value for H. But I've gone and exhausted everything I can get from just looking at or using those like 4 attributes and looking at the picture, right? Notice at no point was I interested in the frequency. Not helpful to me for this. So one of the things that's nice is that I don't ever have to use a negative sign on C. There's infinitely many answers for these. So I can choose whether I want to give an answer with positive C or negative C. They're both possible. For our purposes, my suggestion for you guys is always pick the C to be positive. It never really makes the problem any harder doing that, and will often simplify the process. That's my suggestion to you, is that we're always going to just assume that C is positive. You could write an answer with a negative C. It's possible to do that, but oftentimes it gets a little bit more complicated to do that. So I'm going to always pick C to be positive. That's going to be our choice. My suggestion to you is to just choose C to be positive rather than negative. Okay with that? All right. So now I have 2 things left. I need the sign for A and H. Let's do this as a sine graph first, and then we'll come back and do it as a cosine graph afterwards. Everybody okay with the plan? So the tool that I'm going to use to figure this out is going to be this transformation map that we use to do the graphing. Okay. So what I'm going to do here is I'm going to pick a point from the parent function and match it up with the same kind of point from the transformed function. And I'm going to use that to be able to figure out the sign for A and the value for H. Is everybody okay with that plan? So the first thing I'm going to do is I'm going to pick a point from my parent function. Since we're doing the sine graph, we're going to be picking one of these points to use. The point that I would choose to use for sine is 0, 0. Mostly because it keeps the arithmetic simple. Everybody's okay with that? Now, there are two different kinds of points in this parent function. I have midline points, and then I have extremas. Everybody's okay with that? So I have either points that land on the midline, or I have extremas, maxes and mins. The same is true for cosine, except the midline points are here, and our extremas are there. Everybody's okay with that? All right. So I'm going to go ahead and pick 0, 0, which is a midline point. And I'm going to match that up with some other midline point from my function, from my graph. So I have a midline point here, a midline point here, and a midline point there. Does it matter which one I choose? Not really. Any of them can give me the correct answer, so I'm free to choose. Although the one I choose will affect the answer that I report. So if you choose different midline points, you're going to get different answers, although they're equivalent correct answers. They can all still be correct. Everybody's cool? Which one do you want to choose? Yeah, why not pick 0, 0, right? Okay. So there's one more thing I need to consider when looking at the graph. If I go back and I look at my parent function, notice that after 0, 0, I have a maximum. You guys see that? If I look at our graph, after 0, 0, I have a minimum. Do you guys see that? So those are actually two different kinds of midline points. So I'm going to represent 0, 0 as midline, then an up arrow for maximum. And then I'm going to represent the 0, 0 from my graph as midline, and then a down arrow for minimum. This part is going to tell me the value for A. Since those guys are opposite kinds of midline points, that tells me that the A is negative. Is everybody okay there? Okay. So last thing I need then is my H. Everybody's okay with that? To get the H, I'm going to plug 0 into this which I know has to equal 0. Well, c times 0 is 0, and 0 plus h is h, so I have just h is equal to 0. What did I really just do there? I transformed my parent function into the new type, into the resultant function, right? I plugged the value for x in my parent function into that transformation map, and I know that has to give me the x-coordinate for my transform function, the x-coordinate from the graph. I can use that equation then to solve for h. So if I write out my answer, then I can say y equals negative sine of 1 over 2 x minus 0 plus 0. Yes, Boyd.
Why is the 2 negative?
So because I had different kinds of midline points here. The midline point from my parent function is followed by a maximum.
So it's like reflected.
Mm-hmm. Exactly. And the midline point for my graph was followed by a minimum, because those are opposites. There needed to be a reflection. That's why I told me the A would have to be negative. Is that okay, guys? All right. Let's do the same thing now for our cosine graph. Here's the nice part about this. The only thing that will be different between my sine graph and my cosine graph will be possibly the sign on A and then the value for H. Oh, all right. That's pretty good. Everything else is going to stay the same, so I'm still going to be asking myself whether I want A to be positive or negative, and the value for H. I'm going to do this the same way by using my transformation map that I would use to graph a transformation. So next thing I'm going to do, I'm going to go to my parent function, and I'm going to pick a value for cosine. Which value do you suppose I would pick? I'm going to pick 0, 1. I like having that 0 in the x-coordinate. Everybody good with that? Just as we look at this, notice that 0, 1 is a, what kind of point is 0, 1? That's a maximum, right? Look at the y-coordinate compared to all the other parent function points. That's the biggest one. So I know that's a maximum. That'll be important here in a moment. Because what I need to do now that I've chosen 0, 1 from the parent function is I need to go and pick a point from my transform function, from the graph. The points that I can choose from have to be extrema, so I could pick that maximum, or I could pick that minimum. Does it matter which one I choose? No. Will I get a different answer for each of them? Yeah. Are both answers correct? Yeah. So it doesn't really matter. Which one do you want to pick, the max or the min? Sure, let's pick the max. So that's the point negative pi, comma 2. Okay. Notice that these are both the same kind of extreme point, What that tells me then is that the A has to be positive. So A is 2. And then just like for sine, to find the H value, I'm going to take 0, plug it into the transformation, and that has to equal negative pi. Well, C times 0 is 0. 0 plus H is H. So H is negative pi. And I have everything I need. Keep in mind, the answers that we're giving here are only one of many possible answers. In fact, there's infinitely many possible answers. All you're going to be asked for is to give one correct answer, right? We're not interested in finding all of the representations of this. That's not valuable to us in any kind of way, shape, or form. We just want to have one correct. Let's do one more example of doing this, and then we'll stop and give you guys some time to start on the assignment. Okay? Because this is not trivial, right? This takes a little bit of getting used to, and that's okay. So I want to make sure I provide some time here today so that you guys can start on this while Mr. Kulik's in the room. Yes, sir. Sure. All right. So just like the previous example, I'm going to do this both ways. I'm going to write an answer for sine. I'm going to write an answer with cosines. I think on the worksheet I ask you to do the same thing here. All right. First thing what we look for is we look for the midline, right? Where's that midline at?
1.
Looks like y equals 1 to me. So the k there has to just be 1. Okay. What's the next thing we look for? Amplitude. What's the amplitude in this case?
2.
Well, it's the distance from an extrema to the midline. Yeah, that amplitude is 1. So that tells me the A is 1 or negative 1. Okay. The last thing we are looking for is the period. I like to go on something like this. It's sometimes a little bit tougher to see where a period starts and ends, right? I think the easiest way to tell is just going from like max to max or min to min. So like that's one period. Everybody kind of okay with that? How long is that? Pi units. And if I know that the period is 2 pi times the absolute value of c, that means c must have been 1/2 or negative 1/2. But what do we do with the c's? Always choose them to be positive. Just makes our lives easier. Do you have to do it that way? No, but you can. and it helps, so why not? Sound good to you guys? All right, so we've gotten everything we can just by looking at the graph. Now we have to pick a function to use. So let's say we're going to use sine. If I'm using sine, I want to use the midline point 0, 0. Remember, that's a midline point that's followed by a maximum. So I need to pick some other midline point from this graph. It doesn't matter which one of those I pick. There's a lot of choices. Let's say we pick, I don't know, this one right here. Everybody's okay with that? It's all kind of arbitrary. So that one is pi over 4, or I'm sorry, negative pi over 4, comma 1. And that's a midline point that's followed by a, what comes after that? A maximum. So what can I say about the value for A? It's got to be positive. So that tells me just positive 1. And then to find the H, what do? I plug 0 into Cx plus H, and it has to equal negative pi over 4. Does anybody notice the pattern here when we're doing this? H is just the x-coordinate from our transform function. As long as you're plugging a 0 in, that'll always be the case. That's why I choose to use 0, 0, and 0, 1 respectively. And that's all we needed, right? Oh, Mr. Kulik, that went so fast. Well, once we have it, the process there, it's all kind of the same, so it's not so bad. Everybody's good how I just plugged that in? Okay, let's do the cosine one then. So what point is Mr. Kulik going to choose from the parent function for cosine? Do you remember? 0, 1 is what we used. And what kind of point was 0, 1? It is a max. So I need to go and pick some other extrema from here. And we have lots of choices. So many choices. Which one do you think Mr. Kulik's going to choose? I'm going to pick 0, 1. Right? That looks like a pretty nice one. Convenient coordinates. If you have the choice, why not? I noticed that 0, 1 was also a maximum. So what can I say here? Oh, I'm sorry, that's not 0, 1, that's 0, 2. Mr. Kulik. Yeah, I was going to say 2. That is not right. Since they're both maxima, though, that tells me that the A is positive. And what is the H going to be? Plug that into there. That gives me H, which has to be 0. Right? As long as the x-coordinate here is a 0, that's always going to be our H. Yes, Patrick. Yes. Well, that's really nice. Nice and convenient, right? Will I always be able to do that, Mr. Kulik? Well, no, unfortunately. Well, for these ones where you can pick any point you want to use, yes. But the next set of problems that we look at next time, no, we will not be able to just always be able to use the one that we want, unfortunately. Or not always. Some of the times we will, but not always. Okay, so for homework, you guys should be able to do numbers 5 and 6, and then should be able to do, it's 7 and 8, so let's just call it 5 through 8. And then we should be able to do worksheet, is it 3? Nope. 5. Yeah, that's the one I want. And this will be not this Sunday, but the following Sunday. So what's that, like the 16th or something? I think the 9th is this Sunday. The 16th is 7 days later, I'm guessing. Next time, obviously we'll take questions from this stuff or whatever, but next time we're going to talk about how to go from a description of the graph to the equation. So we're, instead of getting all of the information, you'll get just like a little bit of it, and we'll have to sort our way to the equation from that. Okay? My suggestion to you is, in the 30 minutes or so that we have remaining, is to try to start on this. I would start with either worksheet 3 or problem 7 and 8 that are just like these more difficult ones we just did. So if you run into problems, you can ask some clarification before you have to go and try it on your own later.